endocrinology and diabetes, and I've used it since I was a junior doctor, gosh, 40 years ago, something like that. You can look up any condition in it, and it tells you how to diagnose it and what the treatment is. And this is a relatively new version for hormones and diabetes, and I can look up in here, I can look up, and it actually mentions Wolfram, which is great, and it tells you how to diagnose it, but there's nothing in here about how to treat it. And that's the same with all the medical textbooks really at the moment. Where I'm trying to get to is that the next edition of this, when it comes out, will mention what the condition is and there's a treatment for it. That's where we're all trying to get to. So that's where I'm trying to go with this, as many of us are in research. And then the second thing I wanted to say was this is why I got into this in the first place. Some of you will recognise Kerry Chambers on this picture. On the left-hand side, from 1994, when I was doing an eye clinic with my colleague, Professor Alistair Fielder, in Birmingham, and I saw this brother and his sister who'd come along for an opinion because they both developed optic atrophy. But what I was puzzled was that they'd also both got diabetes. And as you know, for common or garden diabetes, you don't get vision problems in childhood. And that really got me at the time to think, why should that be the case? And was there anything we could do about it? And on the right-hand side, very kindly, Mr. and Mrs. Chambers sent me a photograph of Kerry at her graduation day from Sheffield University, when she graduated with a first in mathematics from university, despite this. And having heard some of the stories today from other colleagues going through uni, it's just fantastic achievement, really, really wonderful. And then the next thing I wanted to show was the timeline about the research that we've been doing in Birmingham as a team over the last 30 years. Now, on the left-hand side, it was 1938 that the very first report was made by a Dr. Wolfram, working in the Mayo Clinic in North America. And that's why this, that was where the name came from. It's named after a doctor who described a family, 9 brothers and sisters, and 4 of them had diabetes and vision problems in childhood. I got involved in this in about 1995 when I was involved in a clinical trial, in a clinical study. Excuse me 1 second. My phone's going crazy. It's my brother. Sorry, John, I'm giving a talk. Very nice. We only speak on Saturday afternoons. So in the 1995s, I was very fortunate to have a supervisor, Professor Sarah Bundy, and went around the UK finding families, and we put together a history of what happens over time at that point. In 1998, Professor Alan Permit in Washington University, St. Louis, found the gene called WFS1, and at that point, with real help from our genetics testing labs in Birmingham, we were able to do genetic testing in the National Health Service to try and make a diagnosis. In 2012, with Denise and Raj and others as well, we were able to get money from the National Health Service to set up a specialist service for people with the condition here in the UK, and for children at the Children's Hospital and for adults in the adult hospital. And in 2013, a PhD student that I had working with me, Saleh Garani, managed to find a potential target that we could target for treatment called P21-CYP. Then a postdoc with me, Dewey Astuti, did a screen of lots of different medicines to see if any of these would work on that target and treat it. And she came across several, of which the best one was a medicine called sodium valproate. And so when we found that, we then applied to the European Medicines Agency for what's called orphan drug designation. And this is a regulatory thing that means that we're allowed to investigate it, and if it works, we can work with a drug company to have what's called market exclusivity to develop it into a treatment to be licensed in the UK. In about 2016, Professor Tamara Hershey in the United States very kindly shared data from the clinic in St. Louis about the progression of eye disease over that time, and we were able to use measure of vision as a marker to see whether a treatment might work or not. And then from 2016, after several attempts, we applied to the UK Medical Research Council, and they gave us money to fund a study to see if this was going to work. In January 2019, the first children were recruited at Birmingham Children's Hospital to take part in this study. And I'm pleased to add a couple of new lines to this list. In October 2024, the last participants will come for their last visits to the clinic in Birmingham, and then that trial will be finished. And then the last line on there is that the statistician will work and look at the results, and we should have an answer, does this work or not, in about April 2025. So you can see from 1995 to 2025, that's 30 years. So that's the length of time it's taken to get to this point from earlier on. And then I wanted quickly to show some important people, because this is a real team here. On the top left-hand side is Professor Sarah Bundy, who is the Professor of Genetics in Birmingham, who had the idea in the first place to see what is the condition, what causes it, what's the inheritance, and was a fantastic supporter and really started research into this condition here in Birmingham. And then the next picture along on the right is my colleague Dr. Denise Williams on here at her retirement party about 8 weeks ago. And I put it on because she started the clinic with me in 2012, when I think we did the first clinics together for Wolfram. And Denise is important because she's done both the adult and the children's clinics. And I have to say, Denise, your cake was delicious as well. It was absolutely fantastic. It was really, really nice. And then you can see Raj Gupta, who was here earlier on, and Raj, as a children's neurology doctor, again has been doing the clinic since the very beginning in 2012. So we'll have known many of you when you were at the children's clinic before we moved to the adults. And the top right is Professor Alan Permut, who's really the father of Wolfram research, because he and his team found the gene, WFS1, back in about 1998. And if he hadn't found the gene, we'd have still been stuck trying to understand what the condition is and how it goes. On the bottom line is Dr. Saleh Garani on the left-hand side, who was my PhD student about 10 years ago, and it was her studies in cell models that found what might be a drug target. And next to her is Professor Zhuzhen Naji, also at the University of Birmingham, who is an expert in neuroscience and brain things, and said we should really try and use this target and see if we can develop a treatment. Because I would never have thought of it. I'm not a neuro doctor at all. So it was her brainchild. And then the lady third along on the bottom, Dr. Dewey Astuti, actually did that drug screen, working very late in the evenings, testing 25 different medicines against the assay to see which one is likely to work, and found sodium valproate to do so. And then Dr. Małgosia Zatika, working with her in the labs, has done a lot of the testing of your samples, patient samples taking part, to try and understand if this medicine might work with those. And then the bottom right is the next generation. So that's my colleague, Dr. Servan Sarkar, who now leads the laboratory in Birmingham, researching into Wolfram and other rare disorders, and he's coming up with new treatments that I will mention at the end that might be the next clinical trial going forward. But he's basically the next generation of research into this condition in the University of Birmingham. So I just wanted to show that because to try and demonstrate that there's a lot of people involved in trying to keep the research going and take it forward as we go. So the other people, and one of them was here later on, is the network of researchers across Europe who've supported this. And we've needed colleagues in Spain, Poland and France in order to do a study in Europe, because it was hard to have enough patients in one country to do so. So Dr. Renica Diaz, who you know was here this morning, and this afternoon rather, leads the study in Birmingham Children's Hospital, and you'll have seen her in the clinic. Dr. Ben Wright leads the study in the adult hospital, and again he looked after the adult clinics before Dr. Aaron Stoic took part in them. Professor Mlinarski is based in Łódź in Poland, and he's got a big clinic of all the children with Wolfram in Poland, and he's been recruiting patients to this study. Dr. Christophe Boursaud is working in Paris, the Pompidou Hospital in Paris. He's an eye doctor, and he's the eye expert in France for looking after the condition, and he's recruited 10 people who've taken part in the study. And then Raj's colleague in Montpellier, Professor Agathe Ruberti, is a children's brain doctor based in Montpellier. She's recruited quite a number of children to the study there. And then on the bottom left is Dr. Gemma Esteban, is a Spanish doctor who leads the Spanish Wolfram Association, and they've got 40 people in their Spanish association, and they've recruited about 18 people to this clinical trial as well. So you can see there's a really nice network now for not just delivering this study, but for future studies in Wolfram as well, to try and find treatments. So the trial I'm talking about today, we've called it the TREATWolfram trial. It's funded by the Medical Research Council in the UK, and it's a partnership between the UK, Spain, Poland and France, hence the logo, and of course funded by WOS UK as well, as supported. You've got the logo there. It's trying to find out whether the already used drug, sodium valproate, can slow down the progression of Wolfram in children 5 years and upwards and adults. And we've chosen sodium valproate because it works on the cell models, because we know it's a drug that protects the brain, because it's been used for decades in children to treat epilepsy and adults as well. So we know it can be safe, it is safe. And because there's already some people with this condition who've been having sodium valproate and they didn't come to any harm. It seems to be safe in that. And what we've tried to do is to do one study. Jamie did a lovely presentation earlier on explaining about the stages of studies, and that you do a phase 1 to look at safety, and then a phase 2 to see if you can do a dose finding, and then a phase 3. Because this is such a rare condition, we've asked the regulators, can we just do this rapid all roll into one? And they've said yes, that's fine. So we're doing what's called a pivotal trial, so just a one study, and they've asked us to design it according to their specification to have all the information needed, so that if it works, we can go straight to apply to get it licensed for use in the textbooks, as I said, without having to do another study afterwards. That's called a pivotal study. And that's why it's got children in it as well as adults. It's got the whole age range. And unfortunately, that's why it has to be what's called a double-blind study, because they want the best quality evidence if we're only going to do one. They want really robust study. So they've insisted that people taking part mustn't know whether they're on the study drug or the dummy medicine. And the doctors and the nurses looking after them mustn't know if they're on the study drug or the dummy medicine. So it's called a two-arm study. One arm gets the sodium valproate, and then the other arm gets the dummy medicine. And it's decided effectively by the toss of a coin, purely randomly, which arm you're in. We were able, thankfully, to be able to have more people randomized to the treatment than the dummy. So for every one person who has the dummy medicine, 2 people have the treatment, because we wanted to increase or maximize the number of people who might benefit from actually having that treatment. Everybody taking part is put into one of those 2 groups by random. We're not allowed to know, as I said, which group they're in. And then they're followed up for over 3 years with tests of eyesight, brains, and others as well, to see, to measure how the disease is progressing. The only person who can see which group people are in is the statistician, Victoria Homer. Nobody else is allowed to know. And even though I bought her cakes and I've made her cups of tea and I've been very nice to her, she's absolutely not given any clue at all as to who's on what treatment. And as I said, we've needed to have lots of centres involved in order to get 70 people, or up to 70 people, taking part in this. What we're trying to find out is we're doing vision, because Tracy and colleagues here and colleagues in the French Association, the American Association and the Spanish Association all said, if you're going to treat anything, can you do something about the vision? So I'm a diabetes doctor. I was quite happy to have diabetes as the outcome, but families said they want the vision the outcome, because that's more important, because you can treat the diabetes at the moment. So we've had to design it to see if we can slow down the vision loss. But we're only using that as a marker. What we're really trying to tackle is what's going on in the brain and the nervous system. And we think the vision is a marker for what's happening in the rest of the brain as well. So that's why we've asked people to do MRI scans to measure the brain volumes and see if the treatment is slowing down any changes in the brain. Of course, we're measuring diabetes as well, but we're also looking at things like hearing to see if it can slow down hearing loss. Quality of life, of course. Balance to see if it's not making the balance any worse. And really bladder function as well, and see whether it can slow down any progression of the bladder. And then, of course, mood and sleep as well. And so the question earlier on to Georgina's about fatigue, we're asking about fatigue as part of this as well, to know. So all of this will be analysed all together. We've got enough people who've taken part to be able to have a definite answer at the end of it. Does it work or doesn't it work? So hopefully it should be clear-cut when we get to that stage of it. So these are the potential outcomes or the potential issues. The first battle we had to do was, what happens if we can't get enough people to take part? So we actually approached, I think, about 90 people altogether who consented to take part. Some of them were not eligible, and unfortunately partly that was because the vision wasn't sufficiently good to be able to measure it for the purposes of the study, and that's because of the time it takes to set up. But we did recruit 63 participants. My statistician assures me that that is sufficient to be able to give a definite answer at the end of this. So that's really important. So we've met the first criterion. The next one is they might stop the trial halfway through because it's for safety reasons. Somebody comes to harm by the treatment. Thank God that hasn't happened. So that hasn't been an issue. The trial might be stopped because somebody's not following the protocol and not doing it properly. That hasn't happened. The trial might be stopped because we have a data monitoring committee that's independent of us, and they can see all the data and they know who's on which treatment. And if there's absolutely no sign of it working at all, they could stop the trial early. They haven't done that. So I'm really, we've met that criteria, so that's okay. Now the bottom one is a tricky one. So there are 3 possible outcomes to this study that we'll find out in April. The first is that there is no difference in the people treated with sodium valproate or the people treated with dummy. The next is that there is a difference in outcomes dependent on the allocation, but it hasn't reached statistical significance. And the third one is the one we want. There is a difference in the outcomes, and it is significant statistically. So I've said to you at the moment that the study is powered. We should get a definite answer. There should be sufficient to be able to answer that bottom one. As regards to the middle one, the regulators have said, if you just miss the primary outcome, i.e. you're improving the vision, but not quite enough to prove it statistically, provided all those other things we're measuring is pointing in the same direction, they'll allow us to apply for licensing to approve it for treatment. So that's why we're measuring sleep and bladder and hearing and diabetes, because the regulators understand it's a rare condition and we're only going to get this shot of it for this drug. So that's hopeful. The one that wakes me up in the middle of the night is that first one. What happens if there's no difference in the outcomes depending on allocation? And I'll have to stand in front of you this time next year and tell you that. And of course that's the one that we're all hoping isn't going to be the case that we've got. Yeah. So I'll come back to that point in a moment. So this is what's going to happen. The last 2 children are taking part in October, in 2 weeks' time, and they'll visit in October. And then once that's happened, we've got 3 months to collect any outstanding information, so any missing MRI scans or blood tests from anywhere around, or mini-best tests or others, and return those to the trials unit. They're hoping then, once they've got all the information they possibly can, to what they call do a data log. That means they won't accept any more data, and they've got the final trial data set to analyse. That will be done by Victoria Homer, the statistician, assisted by her colleagues as well. And they basically disappear for about 2 or 3 months, and they look at everything that's come out on all 63 patients. The vision, the MRI scans, the whole lot. They will come up with an answer, and we have to report back to the funder, the Medical Research Council, about the end of March. And it's about the end of March or the beginning of April when I'm expecting to hear the outcome of this. As soon as I hear, I share that with my colleagues that are here as well, with Tracy through WS UK, and I think we've talked about potentially having a webinar as well for families to join so that we can explain where the results have got to. if the study is a success and it shows that sodium valproate works in Wolfram and slows it down, then we apply to the National Health Service Early Access to Medicine Scheme. So this is a really nice scheme that says, if you've been able to show or prove in a clinical trial that a medicine works, we'll allow you to prescribe it to patients on the NHS free of charge while you're waiting for licensing to occur. So it basically means that from April or May onwards, that sort of time, we could make the medicine available to anybody who wants it in here. Now obviously sodium valproate has got side effects, and the main one that we're concerned about is giving it to people who are pregnant or people who are trying to conceive. So we would obviously, with that limitation, we'd have to follow pregnancy prevention programs, but otherwise it would be able to be available for people. At the same time, we partner with a small or medium-sized company or enterprise who will help us put a package together to apply to the European Union and the Medicines Regulatory Agency in the UK for a license to say, this drug is licensed for use in Wolfram. And then it goes into that textbook that I showed you that we'll be able to use, and any doctor, any GP will be able to look up that book, look up Wolfram and say, oh, that's the treatment, and we can give people that treatment. And we have to put a package of data together, and that's also a chance to actually change it. So at the moment, the tablets are reasonably big, and they're not necessarily easy to swallow, but at that point, we would be able to work and change the formulation, like make a liquid, or granules that you can have on a teaspoon of cornflakes or something like that, hopefully, to make a different formulation to do it. So that's that. What happens if the trial's not a success? So, we've already got applications in, as well as companies going on with this, to conduct other trials. And what we have got now is a really nice network of centres who've got the expertise to look after people and look after them while they're taking part in studies. So it'll be a lot quicker to get the next trial up and running. And you've heard from Jamie earlier on that there's another really good candidate medicine that's already under trial in the States by the company Amylyx, which is really exciting, and we're really hoping that that's going to come to the UK soon as well. There's been a lot of interest in the press, as you will have heard, about drugs called GLP-1 receptor agonists. So these are these fat-busting drugs by the name of semaglutide or Wegovy or Ozempic. They're almost the next wonder drug after aspirin, or that's how they're being sold at the moment. They were designed initially to treat adults with type 2 diabetes, and they seem to make the diabetes much better, but also reduce weight. So then they moved into actually weight loss drugs, and they're used a lot at the moment in children and adults to help obesity. Some recent papers that have come out in the last 4 weeks have shown that actually they're really good at cardiovascular disease and kidney disease as well, and there's even a suggestion that they might be useful in Alzheimer's. They're currently being trialled in other brain conditions such as Parkinson's and Alzheimer's, and there's nice mouse data and cell data to say that they might actually work in Wolfram as well. So that's another area that we'll be looking at for another clinical trial fairly soon to see if these medicines can work in it. And then the other aspect on here is drugs that help the mitochondria. So Georgina mentioned this earlier on, that we think mitochondria in the cells, they're the powerhouse that make the energy, and there's some evidence that they don't work as well in Wolfram, and maybe that's why some people with Wolfram feel very tired a lot. My colleague Slovan Sarkar in the University of Birmingham is experimenting with those on cell models, in fact brain cell models of Wolfram, and he's got some evidence that if you can give energy boosters to these, it really helps the Wolfram models. Some of these are already available, and some of them you can get in nutrition shops. So we're looking to have the next clinical trial as that as well. And then the other aspect is, I borrowed this slide from Professor Fumi Arano, just to show you that there's a lot of other things going on as well. At the top end here is sodium valproate on the right-hand side, and then next to that is GLP-1 receptor agonists, where we're trying to get money to do a clinical trial of those next. Then in the middle you've got Amylyx, which Jamie talked about earlier on as well, and then right back at this end we've got the gene therapy end of things, and the start for the gene therapy will be to try and transfer a corrected gene into the back of the eye to see if you can use gene therapy to treat the eye condition. Now it's been done in principle in a mouse model in America and I think in Italy as well now at that stage. So it's an exciting area. It's a bit further down the pipeline, but it's a really important area for the future. And then the remaining bit will be transplanting tissues where it's been corrected as well, and that's a possibility. So what I want to do is to assure you that there is quite a pipeline of other treatments under development that will be there to test, that it isn't all revolving around just one trial. There's a whole pipeline of other things that are coming as well to do so. And then, coming towards the end, I thought I owed you some explanation, because some of you who've been to these meetings for a while have probably got fed up to the back teeth of hearing me talk about this trial and never coming to an end. And I perhaps want to give some explanation about why it's taken so long for this. I think, first of all, when you've got a condition that affects 1.5 million people, or not that many more, it's really hard to find people who are able to take part, able to travel, and collect together colleagues around Europe to be able to deliver a trial like that. So I think that took us quite a long time to do so. And then because you're crossing borders, every country's got its own ethics committee and it's got its own regulations that you have to cross, so all that had to be sorted out. Because of the length of time, some people who would really like to have taken part weren't able to because their vision wasn't good enough by the time we got there, and I think we all feel really sorry about that. And that I think the things we've learned from this trial means that we can set up the next one much quicker than we have to do with this one. And then I want to explain a little bit about sodium valproate as well. We did apply to the drug company to support it, but it's such a small market for them, it wasn't really worth their while to take part, so we weren't able to do that at the moment. So we had to buy sodium valproate on the open market to do so. Now what you may know is that some tablets, and I've got them in my bag in there, I think, just a second, I've got an example. Yeah, that's what I wanted to show. Most tablets nowadays, when you get them, they come in little foil packages like that some of you might recognise, and you have to pop them out of the foil packages. Now, if you want to do a clinical trial, the foil package is covered in the name of the drug, so you can see exactly what it is. So you have to pop them out of the package and put them in a separate container. Now, the problem is, once you pop them out of the package, you can't guarantee that they're going to be stable and going to be okay. And the regulators say you've got to demonstrate that they're going to be stable outside that package. So we had a 12-month, 14-month period when we had to take them out of the packages, put them in a room temperature, and watch them and check that they stay stable, and then measure them at the end of it to be able to prove. And that added 14 months to the trial setup to do so. And then the other problem was, I'm a veritable pharmacy of medicines in my house. I can show you this. I even bought the wrong medicines as well. In fact, the medicines I meant to bring, which wasn't these ones, are little round white tablets. We had to find a version of the medicine that was a round white tablet. Most of them come as diamond-shaped purple lozenges with the name of the manufacturer embossed on the top of the tablet. And it's really hard to make a match to that, to make it look the same. So we had to find somebody who made little round white tablets, because you can make a little round white placebo tablet as well. So we had to go on the open market to be able to find that. And then we had to find a hospital with a machine that could make little round white tablets that look like that as well. And we found guys in St Thomas's to do so, so that was all right. And then the machine broke. That was the other problem. So when the machine broke, they had to source a new one from South America, from Brazil, and we had to wait for that to arrive. So that came into another issue. Then I should say, and it sounds like I'm making excuses here, so I do apologise, I'm doing that. Brexit was another issue. Brexit happened just before we started this study, and as soon as Brexit happened, all barriers got put up between us and the rest of Europe. And we had to set up European Union sites within a legal entity within Europe and its own drug quality control centre and distribution centre. And if we'd have got the trial done before Brexit happened, we could have delivered it a lot quicker. So that's what. And then, of course, the other thing happened was COVID. So in 2020, after we started recruiting, COVID shut everything down. So people who were in the trial could carry on, but paused the recruitment until we got through COVID, till about September, October 2020. So that sort of added things. So I think those are the main reasons why it took some time. hopefully, we've got through those now, and we've learned from that, and we've learned how to do better clinical trial designs for the future, so they'll be a lot quicker next time round. But that, I think, just hopefully gives you an overview of where we've got to and what the challenges have been. What's been absolutely fantastic, as well as the support from the Medical Research Council, is support from WS UK, Tracy and others as well. And I think without Wolfram Syndrome UK's support, we wouldn't have been able to support families to come to Birmingham, stay overnight, or the travel to do so as well. And it's been absolutely critical for people to take part in that. So really, really grateful, Tracy, for you for that. And also the international patient support groups have done so as well. And then the final bit to say is that there's a whole bunch of people behind this work that I've included, some of them on this side. The clinical trials unit on this side are the people who are actually delivering this, and the Victoria Homer is going to be analysing the results. And then in the hospitals, we've got clinical nurses who've been looking after participants as they're taking part. We've got our international collaborators, and then on the clinical service team, people who keep the patients going. We've got Marie, who's here in the room today, Susan Gleeson, various others, Raj Gupta, Aaron Sturrock and others as well. It's a massive team effort to do this, but the team's in place now, so when we come to do the next study, it'll be a lot quicker to set up. That's the point, really. So I hope that gives you an overview. I think we've got time for 1 or 2 questions if you want, but at least you can see where we're at. And I will be completely transparent. You'll know, as soon as I know, whether it's worked or not. It'll be about next April time. Okay.
Thank you, Tim. So we're all keeping our fingers crossed for next April. So are there any questions from anyone? No?